And now, as promised, here is part 2 of section 6.2, where I explain how to solve the other kind of problem this section is about. The kind of problem where we're asked to find a range or cutoff scores for a certain percentage of values. The top 10%, the bottom 15%, the middle 40%, something like that. So the way we're going to do this, the steps we go through, it helps to draw a bell-shaped curve and label the area that the problem asks about so that you can visualize what it is you're dealing with. Then you need to figure out the area under the curve to the left of the cutoff score that you're looking for. Then use table E or another method to find the z-score corresponding to that area. So this time we're going from an area to a z-score. And then convert from z to x, from a z-score to a whatever you really are interested in, using the formula x equals z times sigma plus mu. And where that formula comes from is if you take the formula for calculating z-scores and you algebraically solve that for x, do what you have to do to both sides to get x by itself on one side. So let's try this out. Again, I'll start by showing you the traditional method, and then I'll show you a couple of shortcut methods. On the notes, you'll find here's one example of a problem that's already worked out. So you can look at this on your own time. But the one I'm going to do for you right now is, this is example 4. It says a reading program is to be administered to the bottom 5% of the students in the district based on the scores on a reading achievement exam. If the average score is 122.6, find the cutoff score that will make a student eligible for the program. The standard deviation is 18. Assume the variable is normally distributed. So this is asking us to find a cutoff score for the bottom 5%. That is, what score on this test separates the bottom 5% of all the scores from all the others, the other 95%. If I were doing this by hand, I would draw a little bell curve and shade in the what I think is about the bottom 5%. It would look something like this. So the bottom is the numbers over here on the left where the small numbers are, and this red area represents about 5% of the whole area under the standard normal curve. So I need to figure out what the z-score is for that bottom 5%. I need to know what's the area to the left of this cutoff point, and that area is 5%, or 0.05. If we wanted like the top 5%, then we'd have to start by figuring out, okay, what percent is to the left of that? But we want the bottom 5%, so 5% already is what's to the left. So now I turn to table E, and I look in the middle of the table, those 4-digit numbers in the middle, where the areas are. And I try to find the closest thing I can find to 5%, 0.05. Well, here I see 0.05 something something. There's a 0.0505, and right after it is 0.0495. So if we wanted 0.05 exactly, it would be somewhere in between those two, about equally close to both of them. So the z-scores that those go with are negative 1.64 or negative 1.65. So for our z-score, since they're about equally close, we can pick negative 1.64 or negative 1.65, or split the difference and say it's negative 1.645. So the z is about negative 1.645. If you did just negative 1.64 or just negative 1.65, that would be close enough. But now we're going to convert that z to an x. Remember, x equals z times sigma, that's the standard deviation, plus mu, that's the mean. So I'm going to get my calculator. Whoops, this was supposed to be a z. I'm going to get my calculator, and I'm going to type in negative 1.645 times the sigma is the standard deviation, so that's 18, plus the mu is the mean, and that's 122.6. So we need to calculate negative 1.6, whoops, this didn't turn on. Okay, there we go. Negative 1.645 times the standard deviation 18 plus the mean 122.6 equals 92.99. That's real close to 93, so I'm just going to round it off to 93 and say, okay, our answer is 93. The average score on the test is 122.6, but if you scored below 93, that puts you in the bottom 5% of all the test scores. Now for the shortcut methods. If you have a graphing calculator, you can go to the distributions menu, select InvNorm, which stands for inverse normal distribution. For the area, you want to give it the area over on the left side of the cutoff point. So here that was 0.05, 5%. And then you want to give it the mean, which was 122.6, and the standard deviation, which was 18. So you'll be asking your calculator for InvNorm of 0.05, 122.6, 18, and it'll tell you that that is 92.99. Second shortcut method is using that online app that I showed you earlier. Make sure you select normal distribution. Give it the correct numbers for the mean. Ours was 122.6. And the standard deviation. Ours was 18. And we're over here on the inverse probability problem. So we want the one where x is less than some number, because we want the bottom 5%. So I'm going to select that and put in 0.05 because we do want the bottom 5%. Then hit calculate, and it gives us the answer right here. The answer is in red. The probability that x is less than 92.99 is 0.05. So it's 92.99 that is the cutoff point for that bottom 5%. So that's how you do that second kind of problem where you're looking for cutoff scores. I have worked out the other examples on the handout. I've posted on Canvas the worked out examples. So you can go in and look at the answers to all my examples. And then you can try the online homework to see if you can do it yourself.